So in the last video, we talked just a little bit about this idea of electric charge of a system, but you might be wondering, what is electric charge, right? So electric charge is a fundamental property of matter. There's lots of work to try to explain where it comes from and how it manifests, but we'll just take it as this sort of fundamental property of all matter. For us, it's going to be a result of either excess electrons or an electron deficiency, which means we either have too many or too few electrons in our matter, right? And that gives us a charged object. So you probably are familiar with this from chemistry. So here's a nucleus, and that nucleus is positively charged. And most matter is neutral, so that nucleus is surrounded by some sort of electron cloud. And so we'll draw 5 charges to represent 5 electrons in this case. So what we have here is a positively charged nucleus and a negatively charged electron cloud. Now, the electrons are the ones that can move around and so forth. So it is the result of having too many or too few of those that actually gives us net charge in some sort of system. So we'll talk a lot more about that when we get into polarization and so forth. But the idea here is just to get you sort of familiar with this. The units of charge are the coulomb. And 1 coulomb is actually really, really big. So what we'll be working with are very, very small amounts of coulombs. So 1 electron, for example, has 1.6 times 10 to the minus 19 coulombs, right? So you can imagine 1 coulomb is a lot of electrons, a lot of excess electrons. And there's a minus sign out front here because this is an electron. 1 proton is exactly the same, as far as we know, but positive. Okay. Now, as we were talking earlier, this idea of current moving across a boundary is really depositing extra electrons or removing extra electrons. So that fundamental principle that we were talking about, the amount of charge in a system is the result of current crossing the boundary, is really the removal or addition of electrons to that particular piece of matter. And if we can argue that there's no movement of those electrons across the boundary, then what we have is a situation where the total charge of that system is conserved. Okay? In future videos, we're going to talk a lot more about the specifics of how electrons move around and what happens when they distort their shapes, when atoms distort their shapes and so forth. But this is just a fundamental sort of introduction to what charge is.